Next 10, 15 minutes is kind of cover some of the technology terms. So what is SaaS? What is platform as a service? What is infrastructure as a service? What are the differences between Windows Azure and Microsoft Online, for example, and when would you choose one versus the other? And then we'll spend most of our time today focusing on the workloads. When does it make sense to move an application to Azure, or kind of true cloud computing, versus when would it make sense to do it on premises or in a traditional hosting model like a Rackspace or a GoGrid or somebody else. So I know you heard from the session this morning that there are a lot of reasons why customers are looking at cloud. Some of it is they want to move from capital expenditures to operational expenditures, and there's a variety of things. What I tend to focus on is mostly around the innovation part. So being able to build something and deploy something that you never would have been able to do on premises. Maybe it's too expensive, you can't buy that many servers, it's too risky, or perhaps you just don't have the bandwidth to be able to do it. Most IT shops can only take on so many projects a year. With cloud, that kind of changes because you can innovate and deploy these solutions so rapidly that you could literally build something in a week or two, and if it takes off, great. You now have a cloud deployed application that can dynamically scale. If it fails for some reason, you haven't invested a whole lot, and you can literally just shut it off. And you're not then worrying about redeploying physical resources and the management aspects of that. So that's where I tend to focus my time, is how cloud can enable this innovative capability within your company and drive business value. So that's how I'll spend most of my time today. Now, we do definitely have things around security and privacy and what do the SLAs look like and pricing and other components that do factor into whether or not an application makes sense to move to cloud versus whether or not you want to manage it and run it yourselves on premises. So we'll talk a little bit about that as well. But to start, I want to kind of give you a highlight of what, these are Shawn Murray's terms, but what are the definitions of the various flavors of cloud computing so that you can get an idea of, when I say MS Online, where does that fall in this bucket, or when I say Windows Azure. So the first is what we call software as a service, and these are what most people think of when they think of cloud. It's an application deployed over the internet, available through a browser. The challenge with those applications, though, are that in many ways they're fairly limited. The UI that you can receive in a browser may not be as good as a software application that you run locally. So the Flash or the Silverlight type applications that give you a richer UI. In most cases, SaaS applications you can't take with you offline. So if you're on a plane and you don't have internet connectivity, it's very, very difficult to do SaaS. So what Microsoft does is we do have SaaS offerings like MS Online, where we deliver email and collaboration tools as a service over the internet. But we also add a different component, which is what we call software. So software in conjunction with services, or software plus services. And what we think that does is that gives us a richer UI, a better ability to do historical trends and analysis and things like that, and essentially a better user experience for the person that's out in the field with their laptop or their PC needing to access these services. So I tend to use the term software plus services. The industry term is software as a service. But if you've ever, how many of you use email through the browser? Outlook Web Access or Lotus Notes or whatever. How many of you use it exclusively as your only client to the web? Right? Most people don't, because they need to take their email with them. They want to have a richer collaboration environment with sharing calendars and things like that that you just really can't do with a browser-based email system only. So they use it as a choice. They use Outlook Web Access or browser-based email when they need to, if they're in an airport or if they're at a customer site and they don't have access to their machine. But they use a richer software client when they have access to that. So that's what we call software plus services. The second bucket is where a lot of people are thinking cloud is today, primarily because of the work that Amazon is doing, but also GoGrid and Savvis and Terramark. There are a number of vendors in this space. And essentially the concept here is you're going to virtualize an application using VMware or Hyper-V from Microsoft or Zen or something like that. And you're going to take that virtualized image and then you're going to run it outsourced in the cloud. The challenge with that solution by itself is that it, again, only gives you certain pieces of it. So if you already have a strong virtualization environment on premises, if you're an expert in Hyper-V and you've got server consolidation down, or you use VMware today on premises and you've got a really good process around that, then moving that VM to the cloud doesn't really buy you a lot. It might save you a little bit of hardware, it might save you some space in your physical data center, but overall you're still managing the app, You're still patching it, you're still monitoring it, you're still spinning up and spinning down these VMs as necessary. So infrastructure as a service, although Microsoft will have a solution in this space this calendar year, we really think that that's primarily for legacy apps that we need to move to the cloud, but you're not going to do a whole lot with otherwise. And where we think the main value for true cloud computing is in this third bucket, which is what we call platform as a service. So platform as a service enables you to abstract all that away. So all you have to worry about is my application needs 5 front-end servers and 5 back-end servers to handle the load that we are expecting, and everything else behind the scenes is managed by Microsoft. So we patch the operating system, we watch and monitor the operating system to make sure that, okay, if there's a problem on your first VM, we'll turn it off and we'll spin up another in a different rack and make sure that you have highly available, highly distributed application that continues to be available to your customers. So platform as a service is where we think we get the most economic benefit from running an application over the internet, because we can dynamically scale it as necessary, we can actually turn them off and move them around, and all that kind of management and operational expertise, you can focus your people on building more line of business applications that add value back to your business. And so most of my talk today will be around the platform as a service offering. Now the fourth piece is something that's also known as information as a service or data as a service. The concept here is you have information, either public data like zip code data or census data, crime statistics, things like that, or you have commercial data like Bloomberg or Nielsen or AP information, and you want to take that data and integrate it with an existing application that you have. And so Microsoft has a product called Project Dallas, but there are other offerings as well that enable you to take your data, host it in the cloud, and then make that data available through APIs or through service calls to your application. So to give you an example, at the Olympics 2 weeks ago, we had an application that a partner built so that if you were going to a particular event, you could actually plug it into your mobile device and it would tell you where is the best place to park that's in a lower crime rate area. And so it would actually do all that, integration with the parking data, integration with the crime statistics, and give you the best place to park for the venue. And that was all based in Azure and Silverlight for the front end. But we think that most data providers are going to go this route. Rather than shipping you a server with data on it, they're going to say, access my data through this service and integrate it as you see fit. If it's free data, it's just consumable by anybody. If it's commercial data, there'll be a subscription or a transaction basis, but you'll pay for the data, but it'll be easier for you to get, and it'll be easier for you to keep in synchronization with whatever application you're writing. And then finally, the last term I say is kind of everything as a service, and it's a little tongue-in-cheek, but the concept here is everything is going to be impacted by cloud computing. Some cases, the server itself will move to the cloud, so Commerce Server, a BizTalk server, SQL Server, the Microsoft offerings will move to the cloud just like Exchange and SharePoint have over time. Or it'll be a component within that application. So maybe you don't need full-blown SharePoint, maybe you just need a workflow component or a document management or versioning control. And so pieces of Microsoft technology will also be enabled as a component or a building block service that you'll be able to consume and make your own application utilize. So we think that everything is moving that direction, but we also don't think that it's going to be 100% in the cloud. There are a lot of applications that don't make sense in the cloud. There are a lot of data sets that, from a security perspective, you need to manage yourselves on premises. But we think that everything that you do today via an IT is going to be impacted by cloud computing, and certain workloads, certain types of capabilities will be delivered as a service, and you should be able to take advantage of that. So where we think real cloud, or true cloud computing, not the per user per month email type stuff, it is cloud, but it's really just a SaaS hosted application. We think true cloud is involving this kind of dynamic scale where you're putting something out over the internet and it's running in multiple data centers in a multi-tenant environment with highly available, highly distributed systems. That's kind of what we think of as real cloud. We think that those 4 scenarios that make the most sense. So I'll talk about each of the 4. The first is a scenario in which you need a massive amount of compute, but you only need it for a short period of time. Maybe you need to spin up 100 servers once a day to do some massive calculation, or maybe you need extra capacity when you run payroll on the 15th and the 31st of the month. Maybe you have some sort of batch process that has to run at the end of every quarter. But the rest of the time, the hardware that you would have bought on premises sits idle. And so we have a couple of customers that are doing some really creative work in this space. One is called RiskMetrics. They're a financial services company. And what they do is every night they spin up 200 servers, or 200 VMs inside of Windows Azure. And they do all these Monte Carlo simulations on all the financial instruments that they monitor. And they run that from 8 p.m. to 6 a.m., 7-8 hours a day. And then when they're finished with all that computation, they turn the servers off and they present the data back to the trading floor and to their customers so that they can make better informed decisions. The great thing about that is they're paying for 200 servers, but they're only paying for that a third of the time. And so normally, if you had to do that yourselves, you'd buy 200 servers. They would sit idle a lot of the time. You can't install other software on it because it will conflict with whatever you're doing. And so as a result, you have all this excess capacity on premises. So the concept here is you run it for when you need it, and you turn it off, and then you're no longer being billed for it. Second customer in this space is a life sciences company that does DNA sequencing. So they can actually look at your individual DNA and predict whether or not you're susceptible to cancer or diabetes or other types of diseases based on your genetic profile. And in order to do that, they need thousands of servers to do this calculation. But then once they do it, they don't need those servers anymore, so they shut them off. And so they spin them up, run them batch process, and then shut them back down. The second category is what we call growing fast, and it's personally my favorite. This is the one that I think really drives true innovation within a company. The concept here is you want to pick off a project, you want to build an application. You couldn't do it on premises because it's too many hardware requirements, or because you don't know what the workload's going to be like, you buy too much. So if you think you need 50 servers, you buy 100 because there's a lot of risk that's involved. And so what happens is on the cloud platform with Windows Azure, you spin up a number of instances. It costs you a few dollars to do. And if it takes off, you have instantaneous scale, and it will automatically grow to meet the demand, and you only pay for the resources as they get consumed. If it fails, you literally just shut it off. And so maybe you've wasted a few dollars or $20, $50, $100 to try something. And if it's unsuccessful, you haven't really lost a lot. So I've got a couple of customers here. One is Kia Motors. Kia Motors did a big Super Bowl ad with us about 3 weeks ago. So if you watched the Super Bowl, do you remember the sock monkey thing that was in the car? That was an ad that they did to drive traffic to their dealerships to test drive their new Sorento. And what we did in less than 3 weeks, we built them an application that their customer could go online and say, I want to test drive this car, I'm in this zip code. And it would generate a certificate for them that allowed them to get a $25 gift card if they went and took this test drive. Well, the customer had no clue how many users would hit the site with a Super Bowl ad. I mean, literally, it was just, we don't know. And so we spun up 100 servers just to be safe. And we started monitoring the traffic on Saturday before Super Bowl. And literally on Sunday night, we were all huddled around our computer watching to see what would happen. Sunday night, we really felt like we had a dismal failure. We literally had 200 or 300 people that hit the site. And we were like, wow, well, that was a waste of effort. But we didn't spend a lot of money on it. It literally, for 100 servers for a day, was like, $200. So it was like, okay, it was a failure. What we didn't realize was that people were watching the Super Bowl, so they weren't therefore on the internet checking this site. And so Monday morning rolled around, and the Today Show replayed the commercial. It was on YouTube. It was on all the top 10 Super Bowl commercial sites that were, popping up on the internet. And we started watching the traffic grow Monday morning through Monday afternoon. And by the end of Monday, we had 5,000 people a minute that were hitting the site asking for a certificate. So it's that kind of unknown quantity, and if it takes off, you need to be ready for it. But you also don't want to take a lot of risk and invest in all of that stuff on premises in the event that it doesn't go well. Outback, Nike, Under Armour, we have Chicago Bears. We have a number of customers that have done work in this space in digital advertising and kind of viral marketing, Facebook integration type sites that really, really take off through this kind of internet connectivity. The third and fourth scenarios are essentially the same, it's just timing. So the first is what we call unpredictable bursting, and that's where normally your application runs at a known state. You know exactly how many users hit it, you know what the traffic looks like. But every so often, there's this massive spike in traffic. And so the example I have here is Domino's.com. So today, Domino's.com is on premises running Tomcat and Java. And they're not a Microsoft shop in their on-premises world. But on Super Bowl, on Halloween, on days when they have this tremendous influx of traffic where people order pizzas over the internet, their on-premises data centers can't handle the workload. And so what happens is they now will burst over into Windows Azure. And we'll be able to take that traffic and the excess or the overdraft protection, if you will, for the demand that day or that period of time. And then when it goes back to kind of normal, we'll just shut those VMs off and everything continues to run on premises. The fourth is the same, it's just more predictable. So now maybe instead of 1 or 2 days a year, maybe it's every Friday. Or maybe it's twice a month during the payroll cycle, or maybe it's holiday buying season where they know predictably what's going to happen. And the example I have here is Coca-Cola Enterprises. So Coca-Cola Enterprises built an e-commerce application in Azure so that all the gas stations and grocery stores that buy Coke through cans and bottles will now order it through an Azure website. And what happens is they have really big traffic during hot months, so they sell more product in the summer. They sell more product during promotional activities like NBA All-Star Game and Super Bowl and things like that. So they have these big influxes of traffic, and then it kind of goes back down to normal. And so based on the predictable models that we built, we can say this is how much computation you need normally, and then this is how much computation you need in these kind of spiky times. So those are the 4 workloads that we feel like make the most sense for Windows Azure in particular, but cloud computing in general. The unknown traffic or the growing fast or the areas where you want to shut on or turn off resources as necessary. We do not think that a regular website with 50 users a day makes a lot of sense for cloud. It may make sense for hosting or outsourcing, but just that kind of steady Eddie, low performing application is probably not the best fit just because of the amount of effort it would take to rework that application. So questions or comments on that? Thoughts about the workloads? Make sense? All right, so with that then, what is Windows Azure? So if those are the workloads or the scenarios that we're targeting, what do you buy? How do you build it? What would that look like? So essentially we have multiple products in this space that make up a platform that truly abstracts away the management of the underlying operating system so that you just have to worry about the app itself. So we sell compute and storage. So you tell us you need a VM, we call it an instance, but same concept. And you need 10 front-end instances, and you need 4 or 5 back-end instances. You kind of generically tell us this is what the application normally requires, and then we spin up those virtualized resources on demand as you need them. Where we think we're a little different, though, is that we provide the management layer, what we call the fabric controller, and that allows us to do all the monitoring, the geo-replication. So if you publish your data to one region in the US, and then you want it to automatically fail over or replicate to a second region or fail over to Europe or be replicated to Asia, we can handle all of that traffic and all of the management aspects of your application from a Microsoft perspective, and you just tell us what you want the app to do. We also, that's what allows us to do the patching the operating system. That's what allows us to, if you have 3 servers running and one has a problem, we'll shut it off and we'll start another one in a different location on different hardware to make sure that the application is always available. So the onus is now on us to make sure that the application is running appropriately based on the infrastructure that you've deployed. And so that's all called Windows Azure. On top of that, we allow you to purchase relational data, so SQL Azure. This is not SQL Server, but it's based on it, and so it allows you to do queries and stored procedures and generic relational data. So think of this as a product catalog or user information or things that require that relational connection that wouldn't normally fit into Windows Azure. Our storage allows you to store tables and files and other types of data, but if you need a relational store, you would put a SQL Azure database on top of your app. And then finally, we have something that we call the Windows Azure App Fabric, which allows for connectivity back to on-premises. So the Coca-Cola example that I told you about, the front end is all in Windows Azure. So the website, you log in, you see all the screens, but the back end is 100% still on-premises in SAP and a couple of line of business applications that they built themselves. And so what we did is we connected the cloud and the on-premises world in what we call a hybrid cloud, or a hybrid application, that allows them to still maintain the control of the data and expose the data that they want to the users that they want, but also give them the dynamic scale of an internet application that has unpredictable loads and millions of users. So that's what the app fabric does, is it allows you to authenticate the users, it allows you to connect back or call home to your applications that are running on premises, and then integrate them with the cloud application that you've built. So that's the platform. And what we think of when we think of developing on Azure is we want you to develop just like you would develop on Windows Server. So it's not just a .NET thing. If you're a PHP programmer, if you're a Java shop, if you prefer Ruby on Rails, if you use MySQL instead of SQL Azure, that's okay. Because all those technologies today run on Windows Server, and we have ways to make them run in Windows Azure. And so what I want you to leave with today is this is not just a .NET Microsoft thing. Domino's, again, was Java and Tomcat. And a lot of our customers run PHP as their scripting language of choice. That's okay. We can host those applications and run them natively within Windows Azure. You can even choose a different authoring tool. So it doesn't have to be Visual Studio. It could be Eclipse, or it could be some third-party tool that has a plug-in that allows you to develop for that environment and publish your application to Azure natively. So with that, so that's what the platform is. What I probably would spend the rest of our time in is how do you buy it, and how does that make sense, and how does this go? So with true cloud computing, we see most customers, they want to start with no risk and no commitment. They just want to try it out. And that's true for Microsoft as well as Amazon and GoGrid and the rest. That they just want to put in their credit card in a portal, pay for a resource, and explore the opportunity. And so we've created a licensing model which we call consumption. And what that does is that literally requires no commitment on your part. You just log into the portal. You say, I need a couple of servers or 10 servers or 100 servers. You put in your credit card and your company information. And you only get billed for the resources that you utilize. So if it's billed monthly. So if you did something in February, you'd get a bill for what you used in February and March. And every month we send you a bill for what you consumed the prior month. We think that's a great way to get started. But the challenge that most IT shops face is, that's great, but I don't want it to be like a cell phone, where I signed up for the $70 a month plan, and then next month I got a bill for $300 because I didn't know that I was roaming, or I didn't know that I was doing something on my plan. So the second model is, once you have a better understanding of what your application does, you can then move to what we call a subscription, and that's the middle column. And what a subscription does is it allows you to say, I'm going to predict that I need to use X resources, and it then gives you a discount based on your prediction, and so you commit to using a certain amount of resources over a 6-month period, and we'll give you a discount based on that. Again, that's not really terribly committed, because every 6 months you can revisit that. You can say, I want to move it up, I want to move it down, I want to make some changes to it. But it gives you a little bit more predictability from an IT budget perspective, and it also gives you the most benefit for the commitment that you're willing to make. And then what's going to happen over time, probably late summer, but sometime this year, we'll introduce what we call volume licensing. So just like today you buy Exchange and SharePoint and Office via Select or NEA, you'll be able to say, I would also like to purchase Azure as a component and part of my overall licensing agreement with Microsoft. And so you'll be able to commit to that on a 1-year, 3-year basis, and you'll be able to say, this is what I need from a cloud computing perspective annually. So those are the 3 models. Today we have consumption and subscription, and moving forward we'll also have the VL integration. Now you can see down below we have all the pricing aspects of it. So compute or instances or VMs, it's roughly 12 cents an hour for the kind of core or small VM unit that we provide. So that equates to a little over $1,000 a year for a VM or for a single instance. And so you can see where a traditional website hosting a couple of users a day, that doesn't make a lot of sense, because it's $1,000 versus $200 a year for some of these kind of low-end website hosting providers. But if you need to spin up 2,000 servers a day, or you need to start spinning it up and spinning them down, all of a sudden that pricing model starts to make an awful lot of sense. So we see most customers, the average size deal for an Azure deal is actually, a few thousands of dollars as opposed to millions of dollars. And again, that investment, if you try something and it takes off, great. You'll pay for the resources as you continue to consume them, but you haven't really invested a whole lot to begin. Storage, 15 cents a gigabyte a month, so that's a daily average. So if you upload a lot of reports or documents or files or videos or photos or anything like that, we'll charge you at the end of the month based on how much storage you had on a daily average. So that's very, very inexpensive, and we see a lot of customers starting with storage first. So I want to take an application and take all my archived reports, or I want to take all these PDFs of my annual reports or my news information, whatever it may be, hosting it in Azure as just a raw storage mechanism or a backup type of a utility. And then over time, they start to move it more into compute where they say, I'm going to take some CPU and I'm going to do some analysis on that data. And then finally, the last charge is bandwidth. So we'll charge you for the bandwidth or the network going in and out of our data center. Now that could be to your data center, or that can be to your end customer that's connecting to the application and consuming the service. But one of the things that we offer here is we want to make it easy for you to onboard your application. So we do things like allowing you to upload your data for free in the off hours. So if you've got a whole bunch of data and you need to get it to the platform, you won't pay the 10 or 15 cents a gigabyte to upload it as long as you do it after hours, like after 6 or 7 p.m. Do it in your time zone, batch process or upload it overnight, and you won't get charged for that. So we are trying to work out ways that you can quickly and efficiently get your data to Azure, and then you're only paying for the resources that your actual customers or your actual employees are utilizing. So it's available in multiple countries today, 21 countries today, and we're rolling out additional countries over the next few months. We have multiple currencies that you can consume Azure in. We see not only a great presence in America, but we also have these data centers in Europe as well as in Asia. And we do have the capability to replicate that data across a geography. So in the event that you have an application that you want to make available in the US, and then you want to take that exact same application and make it available in Asia, we can handle that replication for you if you like. Or you can redeploy that application to Asia separately. It's totally up to you kind of how you approach that. So what I would recommend is that you take a look at your applications that you have. We think that there's going to be kind of 3 layers of analysis. The first will be you're looking at your entire portfolio of applications. You have 100 apps, you have 1,000 apps. You want to start looking at which ones may make sense to move to a cloud computing model. Again, keeping those workloads or those scenarios in mind and keeping the net new, I want to build something new, maybe I'll build that in the cloud first and see how that goes. So you look at all your applications, you start to analyze them. The second layer will be then, once I have identified a few applications that may make sense, do the deeper analytics around what would it take to get that application moved to the cloud? How do I manage state? How do I change the application to be cloud aware, if you will? And then the third model is, or the third level is who actually does the work. Do you build the application yourself? Do you have a partner? Do you have Microsoft Consulting Services? Who can help you come in and do the skills transfer and actually do the custom development required to get that application ported over to Windows Azure? Now, in many cases, that app, if it's a .NET app, actually requires no rework. If it's written in the right way, we'll just move it over natively. In many cases, it might take a little tweaking, a little analysis, but overall, it's not a big work effort. In other cases, if it's a long history legacy application with a lot of integration and a lot of working parts, that may be a very, very challenging project to move forward. And you have to determine, does it make sense to rewrite the entire app? Or are there pieces of that application that I can peel off and provide as a cloud-based service? So we think that kind of deep analysis on what your applications do, where they run, who accesses them, which ones make sense for the cloud, that's the process that an enterprise customer should go through. So we provide what we call a TCO tool. And what that does is that allows you to, it's like an Excel spreadsheet essentially. You plug in your numbers. So today it's an existing app. I have it on 5 servers. I have 3 people that manage it. This is what it looks like. This is how much I spend on development and maintenance. And you plug in all your numbers, and then it spits out a result that says, here's how much it would cost you on premises, here's how much it would cost you with a traditional hosting model like a rack space, and then here's how much it would cost you to run it in Windows Azure. What's great about the tool, though, is you can go back in and you can tweak every single value. So if we've assumed that you pay $150 an hour for a developer consultant, but you only pay $80 an hour, you can go in and you can tweak every number. And so the actual output of that result is your true numbers around what you predict the application to cost. Now, if that's a legacy app, it works very, very well. It also works very well if it's a net new app. If you have no idea what the application is going to look like, you can plug in the type of app. So it's an e-commerce application. We expect this many users, and we expect it to be in these locations. A transaction will likely be this size. So you can fill in the what-if scenarios, and then it will spit out again an analysis, both a 1-year and a 3-year analysis that says this is roughly what we think it will cost you. It's not a pricing, it's not a quoting model, but it'll at least give you a concept. And the great part about this tool is it spits out the data in Word, Excel, and PowerPoint. So you can then take that business analysis and report it back to your CFO or report it back to the appropriate project manager to say, look, I think this makes sense to take a deeper look and moving this application to the cloud. And again, it is a developer platform. So today, you can rent these resources yourselves. You can have a partner build an application and run it for you on your behalf. Or you can have Microsoft Consulting Services or someone else come in and do the work. But at the end of the day, Windows Azure is a platform by which developers can build applications and deliver them over the internet. So we think commercial or enterprise customers have a lot of needs to move these applications. And we think that ISVs and partners will start to provide applications on top of Windows Azure, just like they do with Windows Server today. So today we have thousands of partners and thousands of applications that you can run on Windows Server. You can actually now do that via the cloud as a SaaS or a software as a service offering. Yeah?
Quick question.
Sure.
Okay. So one of the bigger challenges for, I guess, small and medium-sized businesses is having a matching dev environment because there's a substantial amount of cost and probably even more of a cost in terms of the man hours of keeping a dev current with your production system and mirroring those two so when you actually go make a change, it's meaningful.
Yep.
Is this something where you could export periodically a production system like a SharePoint and then have something in the cloud that the guys could go bang on and destroy if they wanted to, and then, you know, if they destroy it, you push a button and it comes back?
Yeah, so the question is a good one, and I'm going to answer it two ways. So the actual question you asked, which is, can we do that in a dev and test for something that's existing today? We can, but for something like SharePoint or Commerce Server, something that's a finished server application, we don't yet have the ability to install that in Azure and then do testing on it. But if
I might take issue with you saying SharePoint is a finished server application.
well, as a server product that you can purchase. But what we do see is customers that are using Azure for dev and test today. So you can spin up these environments without investing anything. And in fact, we even have integration with MSDN. So if you have an MSDN universal subscription today, you actually get Azure as part of that. And so you can deploy applications and start testing on it. What we don't have today is the ability to build it in Azure, and then when you're ready, move it back on premises and run. So it works very, very well if you build it in Azure and then deploy it to Azure. And what you're going to see over the next year or so is we're going to have that kind of back and forth integration where stuff that we do on Windows Azure will be able to be consumed by Windows Server and vice versa. An example of that is Windows Azure built this piece called Boot from VHD, so you can actually boot a server to an image. That technology then made its way into Windows Server 2008 R2. So we see this kind of technology exchange between the server group and the Azure group. And once that gets more cohesive, you'll be able to do that back and forth. So today, you can do dev and test if you're moving to the cloud, or you can do dev and test between cloud versions. So you have a production app, and you have a sandbox development app in the cloud, and then you can swap the two environments just with a click of a button. Over time, you'll see the dev in the cloud back on premises. What else? This is a good stopping point for other Q&A or thoughts or comments. Okay, so the last thing I'll say is that just like our approach for Exchange and SharePoint Online and the other MS Online offerings, we truly want you to have an enterprise experience. So unlike a lot of the other cloud providers that focus on the consumer market or focus on kind of the end user state, we really are approaching our cloud offering from a commercial enterprise perspective. So as a result, we have obviously consulting services and partners and deep integration at that level to be able to enable you to build applications. But we also then integrate that with our services arm so that you can troubleshoot applications if you have problems with them. So we'll troubleshoot the Azure environment. We'll help you debug your code from a Premier Services perspective. We have technology and resources to do that. So we treat this just like any other server product that you would buy from us. We back it up with telephone support. We allow you to have that kind of rich end-to-end experience from building, deploying, and iterating on the platform. So definitely talk to your Microsoft representative, both from a services perspective or from an account relationship perspective, and see if there's an opportunity for us to look at an application to help you move into the cloud. And with that, I'll just say we have a lot of customers that are doing a lot of work on the platform. I mentioned a number of them today. And hopefully what you'll see over the next few months is that we continue to have additional case studies and evidence around this platform. And I would just recommend that as a kind of next step, go out to azure.com, download the SDK, get yourself a trial platform account, and start working on the platform. Thank you very much.